Hey guys, welcome back. In the last session, we had a discussion about object. In today's session, we are going to discuss about class. What is a class? A class is a template, which itself is something abstract, but it defines what is going to be there in an object. A class is a template, which itself is something abstract, existing in theory, not practically. Because what practically exists at runtime is an object. A class is a template, which itself is something abstract, but it defines what is going to be there in an object. Analogous to class in real world. If you go to book a flat somewhere and the builder has not done anything, he's not even made a sample flat. It's just a barren land. What he's going to show you? He's going to show you floor plan. That floor plan that he's going to show you is a class. It's a class. There, he's going to tell you, this is a living room. This is a bedroom. Is it there? No, it's not there. Abstract, existing in theory, not practically. Okay. But the actual floor, when built, that living room and bedroom will be there. That actual floor, when built, that actual floor is an object. This floor plan is a class. Okay. A class is a template, which itself is something abstract, but it defines what is going to be there in an object. That floor plan is a class, and the actual floor when built is an object. Okay. You have floor later. First, you need to make a floor plan. Similarly, class is first written, then we'll have objects. And that object is going to have exactly the same things that you define in a class. And in the last session, you did see what can be there in an object. What can be there? Variables, methods, or in other terms, state, behaviors. I'll be talking in two ways. Sometimes I'll be talking logically. Sometimes I'll be speaking syntactically. When I speak logically, I'll be calling them state and behaviors. And when I'll be speaking syntactically, I'll be calling them variables and methods. So now whatever variables, whatever methods, or whatever state, whatever behaviors you need to be there in an object, you need to first define them in the class. Whatever state, whatever behaviors, whatever variables, whatever methods you define in a class will be there in an object. An object is an instance of a class. It's an instance of a class. A floor plan, actual floor is an instance of a floor plan. And as you can see, there can be n number of floors, n number of instances. So one class can have n instances, n objects. Now the next thing that I like to do, I like to show you how to write a class using Java syntax. Okay. Let's write a simple class and see the syntax for writing a class. I'm going to use edit plus editor to write that class. All my Java source code, I'm going to write in that edit plus editor. There are many editors. You can use any editor, even you can use Notepad. Okay. But about the editors and the IDs, we'll be discussing it in next session. Right now, the focus is OOPS, and we'll see how to write a class. And the editor that I'm using is edit plus. Let's see the syntax for writing a class. Okay, so here we write the class. Look at the syntax. The keyword class, lowercase, space, name of the class. Let's say A. Then opening brace of the class. Now inside here, we need to put whatever state, whatever behaviors, whatever variables, whatever methods, we need to be there in object of class A. We need to put it here. We need to define it here. Now let's say I don't want any state. I don't want any variables. I just need one behavior, M1, one method, M1. So let me put it. Let's put it. Public void M1. Open the brace. Now within this method M1, within this behavior method M1, I write some line of code. System.out.println println hi. Okay. So I've just written one line of code inside this method. Let's not get into the syntax of this line of code, which I'm going to explain you later. Right now, just understand that if this line of code executes, hi will be printed on console. Hi will be printed on console. So I've written this class, a class by the name A. I've put one behavior. I've defined one method inside this class, M1. And I've written one line of code inside this M1 method, system.out.println hi, which I explained you. If executes, will print hi on console. Okay. At runtime, what will we have of this class? Object. That's what we discussed just a short while back. A class is a template which itself is abstract, something abstract, existing in theory, not practically, because practically at runtime, what will exist is an object. So at runtime, we will have object of this class, something like this. Okay, so here it is. At runtime, we'll have object of class A. And what's going to be there inside? One method, one behavior, M1. Okay, one method, one behavior, because that is what we defined in the class. Whatever you define in a class will be there in an object. So in this object of class A at runtime, we'll have one method, one behavior, M1. Now at runtime, someone can have a reference to that object. Someone can have a reference to that object. Let's say A. Now someone who has a reference to this object can do what? What can he do? He can access whatever is there inside. And what's there inside? One method, one behavior, M1. So he can access that M1 method. Accessing a method is calling a method. So someone who has a reference to this object can call this method M1, can call. Now whether he calls it or he doesn't call, that is totally his choice. If he calls that method, that line of code which is written inside that method will get executed. And as you know, as I told you, that hi will get printed on console. But if he calls. Now, one of the features of object-oriented programming is inheritance. We can write a class which inherits from some other class. Like here also, I can write a class, let's say B, which inherits from class A. If I write a class B, which inherits from class A, it will inherit. What will it inherit? All the characteristics of class A will be inherited in class B. Okay. In such case, what are those classes called? Class B inherits from class A. What are those classes called? There are three pair of words which are used. Class A as base class, class B as derived class. Class A is a superclass, class B is a subclass. Class A is a parent class, class B is a child class. So there are three pair of words which is used: base, derived, superclass, subclass, parent, child. You are free to use any pair of words. I am generally used to calling them superclass, subclass. So now that is the next thing that I'm going to do. I'm going to write a class B which inherits from class A. So in our case, that A will be a superclass and B will be a subclass. That way we'll be able to see the syntax in Java for inheritance. So let's see, let's go and write class B once again in our edit plus. Okay, so let's look at the syntax for inheritance. Class B extends A. Look at this, extends. It's a Java keyword, lowercase. This is the keyword for inheritance. Class B inherits from A. So what will happen, as I told you, whatever is in A, whatever characteristics are there in A will be inherited in B. What is there in A? Only one method, one behavior, M1. So that will be inherited in B. Okay. A is the superclass, B is the subclass. Class B extends A, open brace, close brace. I don't do anything inside that class. I don't do. Again, at runtime, what will we have of this class? Again, at runtime, we'll have object of this class, something like this. Let's see. So we'll have object of B. Here it is, object of class B. Again, what will be there inside? One method, one behavior. Which one? M1. Though I did not define anything in that class B, then also I'll have that M1 method in object of B. Why? Because B inherits from A. So it will inherit that M1 behavior which is in A. So even object of B will also have that one method, one behavior M1. Again, someone can have a reference to this object. Let's say B. Now someone who has a reference to this object again can do what? Can do what? He can access what is there inside. And what is there inside? One method, one behavior, M1. So he can access that M1 method inside. Accessing a method is calling a method. So someone who has a reference to object of B can call that M1 method. Now if he calls, again that line of code will get executed and what will be printed on console is hi. Okay. Now if you look at these two objects, object of class A, object of class B, they both have one behavior, one method, M1, M1. Calling a method is invoking a behavior. Calling a method is invoking a behavior. If we are invoking M1 behavior on object of A, it is behaving. How it is behaving? By printing hi on console. Similarly, if someone is invoking M1 behavior on object of B, again it will behave. How? By printing hi on console. So if you look at both the objects, they both have one behavior M1, and that behavior is also behaving in the same way by printing hi on console. So the question comes, is there a logical difference between the two? At least right now, no logical difference. They both have one behavior M1 and they both are behaving in the same way. Since they don't have any logical difference, so the question comes, why did I write class B? Why? I could have created two objects of A. Remember, an object is an instance of a class and you can have n instances of a class. So I could have always, if I wanted two objects, I could have created two objects of class A. There was no need to write class B because here, if you see, there is no logical difference between the two objects. So listen, to be honest to you, we use inheritance. We do inheritance. We use it, but not the way I have done it. After inheriting, we do some things. Now what do we do? After inheritance, there are two possibilities. We can do two things. One, we can add more characteristics. That class B, that subclass that we have written, inside that, we can add more characteristics which are maybe specific to B. So maybe in class B, I can add one more behavior, one more method, let's say a method by the name M2. In fact, let's go to edit plus and let's do it. Here is, in class B, I give one additional method, public void M2. Okay. And inside this method, again, I write a line of code, system.out.println, let's say by. Let's say by. Now, in object of B, not only will there be a method M1, there will also be a method M2. Let's go and see. Now, in object of B, object of class B, not only will there be a method M1, there will also be a method by the name M2. Now, someone who has a reference to object of B can not only invoke M1, he can also invoke M2. Again, whether he invokes it or not, whether he calls it or not, that is totally his choice. But if he calls M2, what will happen? By will be printed on console. So now you can see at least there is some logical difference between the two objects. That object of class A contains only one behavior, while object of class B contains two behaviors. Now you can see some logical difference. So one thing that we can do after inheritance is we can add more characteristics, which are maybe specific to that subclass. In our case, which are maybe specific to class B. So that is one thing that we can do. What is the second thing that we can do? The second thing that we can do is we can modify the inherited behavior. Now, as far as class B is concerned, which is the inherited behavior? M1. M1. That's an inherited behavior. We can modify that behavior. Now, currently, if you see, if someone calls M1 method on object of B, how it is behaving? By printing hi on console. Exactly the same way as it is behaving in object of A. So there is really no difference. It is behaving exactly the same way in both the objects. Now let's say I want to modify. What I want that if someone calls M1 method on object of B, it should behave in a different way. It should behave in a different way. Instead of printing hi, it should print hello on console. Hello. I can do that. I can do that modification. How can I do that modification? What I'll have to do? I'll have to redefine that M1 method in class B. I need to redefine it. Let's go and do it. Let's redefine and modify the inherited behavior. Let's go to our edit plus. Now here I redefine the method. Public void M1 system dot out dot println hello. I redefined it. And you know, this redefining what I did is what is called method overriding. This is what technically is called method overriding. But then remember, redefining will come into picture only if it is already defined. If it is not already defined, there is no question of redefining. So what I mean to say, method overriding comes into picture only if there is inheritance. If there is no inheritance, there is no question of method overriding. Okay. So if you want to modify, you need to override. If you don't override, if you don't redefine it, that inherited behavior will behave exactly the same way as it was inherited. So that is what is method overriding. I hope you got it. There is also one concept of method overloading. Now, what is this concept of method overloading? We can have more than one method. We can have more than one method with the same name in the same class. We can have more than one method with the same name in the same class, but the compulsion is that it should differ in parameters. They should differ in parameters, either number of parameters or type of parameters or order of parameters or any combination of three, but they should compulsorily differ in parameters. So now let's do that also. We already have a method M1, and now I'll give one more method M1. I'll overload it. One more method M1 I'm going to define in class B. But as per the method overloading concept, it has to differ in parameters. So this M1 currently which is defined does not take any parameter. Right now the method M1 that I'm going to give will take parameter. Let's say string. So let's do it. Okay. Public void M1. Okay. M1 which takes a string. It should compulsorily differ in parameters. That previous M1 method is not taking any parameter. This is taking a string. Inside this, system dot out dot println s. Okay. So now we have overloaded methods. Now someone who has a reference to object of B can not only invoke no parameter M1, he can also invoke M1 which takes a string. So when he calls M1, it depends. If he doesn't pass any argument, that no parameter M1 will get invoked. But if he passes a string, the parameterized M1 method will get invoked. So this is what is method overloading. So if we go and see the figure, first I did modify the behavior M1. Instead of printing hi, printing hello. And I also gave one overloaded method M1 which takes a string. So now if you look at these two both objects, this object of class A contains only one method, one behavior M1, while object of class B contains three behaviors, three methods. M1, parameterized M1, which takes a string overloaded, and M2, and out of which this no parameter M1 has been overridden, redefined. Okay. So after inheritance, there are two possibilities, as told you. After inheriting, one thing that you can do is you can add more stuff, add more characteristics, which are maybe specific to that subclass. And the second thing that you can do is you can modify the inherited behavior. Modify by method overriding. You also understood the concept of method overloading. You can have more than one method with the same name in the same class, but they should compulsorily differ in parameters, either number of parameters or type of parameters or order of parameters or any combination of three. But now, also one thing I'd like to tell you, method overloading. More than one method with the same name in the same class. Now something to wonder, why will we ever do it? Why will we have more than one method with the same name in the same class? Are we running short of names? No, not at all. There are so many names available. Then why will we do that? Why will we do that? As you know, method names, every one of us gives them sensibly. How do we decide the name of a method? We decide the name of a method by the work that it is doing, by the operation that it is performing. That decides the name of the method. That's the logic we use to decide the name of a method. I give you an example. Suppose I want to write a method in which I want to calculate area of a rectangle. So what do you think I'm going to keep? The method name. What method name I'm going to keep? Calculate area. And that calculate area method will take two parameters, int length, int breadth. And that method will calculate the area of a rectangle. Okay. Now let's say I also want to give a method to calculate area of a square. Again, don't you think the work to be done is same? I want to calculate an area. Since the work to be done is same, doesn't the logic say that the name of the method again should be calculate area? So now here you are talking about more than one method with the same name. You already have given calculate area method to calculate the area of a rectangle. Now you're talking about to calculate area of a square. So again, since the work to be done is calculation of area, again the logic says that the name of the method should be calculate area. So maybe I'll give an overloaded method. Again, the name will be calculate area, but this time this method will take only one parameter, int edge. Okay. So what I mean to say is, when do we use overloaded methods? When the operation to be performed is same. When the operation to be performed is same, but on different data. At that time, we use overloaded methods. I hope this clears the concept of method overriding and method overloading. Okay. Now proceeding ahead. As in C, as in C++, as in Java, application starts from main method. Application starts from main method. In Java also, application starts from main method. But unlike C++, in Java, that main method has to be in some class. In your C++, you can have a standalone main method. But in Java, any method, main or no main, needs to come into some class. So now I again go back to my code. Now I'm going to write one more class, class C. And in that, I'm going to give a main method. And remember, my application is going to start from that method, main method. So let's go into our code and write one more class C where we put the main method. Here it comes. Now one more class, public class C, public class C. Okay. Now I'm about to give the main method inside this class. But before I give the main method, one thing to observe, look at this, public. In the previous two classes, I did not use this public. Now what is this public? It's an access modifier. Access modifier. Let me tell you, in Java, we have 4 access modifiers. 4. Public, private, protected, and default. Default access modifier. when you don't give any access modifier, like here in class A, class B, I have not given any access modifier. When you don't give any access modifier, it is also one type of access modifier in Java, which we call default access modifier. It's also known as friendly access modifier. Whatever, you can use the word default, you can also call them friendly. I'm generally used to calling it default. So in Java, we have 4 access modifiers: public, private, protected, and default. But remember, 4 access modifiers are for members of the class, And what can be a member of a class? Variables, methods, they are members of the class. For members of the class, you can use 4 access modifiers, any one of those 4. But as far as class itself is concerned, for the class itself, you can only use 2 access modifiers, either public or default. You can't use private and protected. Please note that. So total 4 access modifiers in Java: public, private, protected, and default. For the members, you can use all 4, but for the class itself, you can use only 2, public and default. Can't use private and protected. Okay. So this was about access modifiers. Now, yeah, one question that should come up in your mind is, what is the difference in the access between these 4 access modifiers? Definitely, I'm going to tell you what is the difference, but maybe this is not the right time. I'll have to do one topic: packages. Once I'm done with those topic packages, I'll be in a position to tell you the difference in the access between those 4 access modifiers. So let's hold on till that time. Right now, you just remember that there are 4 access modifiers: public, private, protected, and default, but 4 for members of the class. For the class itself, only 2, public and default. Can't use private and protected. So if you look at our source code for class A and class B, I have used default access modifier, and for class C, I'm using public access modifier. Now in this public class C, I'll give the main method public, and my application is going to start from the main method. Public static void main takes parameter string args square brackets. Okay. Again, let's not go into the syntax of this main method, which I'm going to explain you later. Right now, only understand that the name of the method is main, and keep in mind that your application is going to start from main method. Okay. So let's get into this main method. Look at the very first line of code that are right inside this main method. A, comma, A1, A, comma, A1, okay, semicolon, okay. Sorry, yeah, A, comma, A1. Look at this line of code. Just try to think. What do you think I'm doing in this line of code? In fact, this will be the first line to get executed. Just guess. What do you think I'm doing in this line of code? When I ask my students, what do they think that I'm doing in this line of code? Many of them reply me that we are creating 2 objects of class A. Small a and A1 are 2 objects of class A. We are creating objects of class A. The answer is totally wrong. No. This line of code definitely will not create any object. So if it's the same thing that is going on in your brain, that this line of code is going to create an object, no, it's not going to create an object. We are not creating objects. Okay. At runtime, when this line executes, no object is going to get created. So what are we doing in this line of code? What are we doing in this line of code? We are declaring variables. We are not creating objects. We are declaring variables. Most of you must have done this thing many a time. Int I, comma, j. Okay. Int I, comma, j. This is something that you must have done many a times. What are we doing in this line of code? Int ij. Aren't we declaring variables? Yes, we are declaring variables. 2 variables. I, j of type int. We are declaring variables I, j of type int. Int, it's a primitive data type. And this I and j, they are called primitive data type variables. Primitive data type variables, primitive data type. Declaring variables. Now the same thing you compare here. Here also, we are declaring two variables, A1. Like here we are declaring I and J. Here we are declaring A and A1. Here I and J are the variables. Here A and A1, lowercase a and A1 are the variables. I and J are primitive data type variables. A and A1, they are called reference variables. Their reference, you are declaring reference variables. Okay. Int is a primitive data type. It's a primitive data type. And if you look at this capital A, it's actually a name of a class. Actually a name of a class, which we had written already. But if you look at this, and if you compare it with this line of code, if you compare this A and this int, don't you think this A, I am using it as a data type. It's actually a name of a class. I am using it as a data type. Now, when we defined class, what did I say? A class is a template, which itself is something abstract, And here, if you see, I am using it as a data type. So let me here tell you, that's why classes are called abstract data types. You must have read this in many books, abstract data type, but I hope now it's clear why classes are called abstract data type. So here in this line of code, we are actually declaring two variables, A and A1, reference variables of type A. This A is an abstract data type, declaring variables. Declaring two variables A, A1 of type A. Primitive data type variables, int ij, once again, int I comma j. What can you store in a primitive data type variable? What you can store? You can store a value. In a primitive data type variable, what you can store is a value. In a reference variable, what can you store? Reference. In a primitive data type variable, you can store a value. In a reference variable, you can store a reference. And reference, whose reference? Remember, reference is always of some object. Reference is always of some object. Like here, when you're declaring int ij, what are you doing? You're actually declaring the potential. What can be stored in I and j? Any int value can be stored in I and j. Similarly here, you're declaring the potential. What can you store in A and A1? You can store reference of any object of class A. What you can store in A and A1? Reference of any object of class A. That is what you're declaring the potential. I hope you understood this first line of code. So when this line of code executes at runtime, there won't be any objects created. There only will be created two variables, A and A1. In fact, further, I'm going to write a code which is going to create object of class A. And when we will have object of class A, we will have reference of that object. And when we have reference of that object, we are going to store them in this A and A1. Right now, we don't have any object, so there is no reference. So when this line executes, only two variables will get created, A and A1. So I hope you understood the technical terms. A and A1 reference variables, capital A abstract data type. Declaring variables. We are declaring two variables, A, A1 of type A. We are declaring the potential. What can be stored in A and A1? Reference of any object of class A is what can be stored in A and A1. Now let's move on to the second line of code. B. Okay. B. Again the same thing. We are declaring variable. Declaring variable B, lowercase b, to be of type B. B is also a class we have written. As you can see, in fact, one thing, B extends A. Extends. You know, this extends is what we call inheritance, is what we call is a relationship. Is a relationship. Inheritance is a relationship. To better understand, if I take an example, class car, class Toyota Innova extends car. Toyota Innova inherits everything which is in car. So Toyota Innova is a car. So that inheritance is a relationship which we call is a relationship. Again, let's come back. B. We are declaring variable B to be of type B. Now the third line of code. A is equal to new A bracket bracket. Now look at this line of code and try to think, try to imagine, try to figure out what do you think we are doing in this line of code. In this line of code, we are actually creating an object. This line of code will create an object. Now, if you look at this line of code, A is equal to new A, open the parenthesis, close the parenthesis. It's an expression. Left hand side is equal to right hand side. Look at this right hand side. New A, parenthesis open, parenthesis close. This right hand side will actually create an object of class A. So when this executes at runtime, it will actually create an object. So this is how objects are created in Java. New followed by call to the constructor. So that is how objects are created, using the keyword new followed by call to the constructor. We are giving a call to the constructor. This will create an object. New will return the reference of the newly created object, which on the left hand side, we are collecting in variable by the name A. So at that point of time, that A variable, now that reference of that new object will get stored. So at this point of time, that A will have reference to that object of A. New followed by call to the constructor will create an object. New will return the reference which we are collecting in A. Okay. So if you look at the figure, at this point of time, this A will have reference to this newly created object of A. Okay. New returns the reference. New returns the reference. Now the question is, what is a reference? Most of the students, they have the impression that reference means memory address. Reference means memory address. Maybe, may not be. Actually, you know what is the basic definition of reference? The basic definition of reference is some way to access a resource is called reference to that resource. That's the basic definition of reference. C and C++, Borland C, Turbo C, they are a product of a company and they use memory address as a reference. That's why most of the students have the impression that reference means memory address. But let me tell you, JVM, Java Virtual Machine, is not a product of Sun Microsystems. It is a specification given by Sun, and there are many vendors who give JVM. Not all the vendors use memory address as a reference. Some use it, some don't. Okay. In fact, here also 80% of the vendors, they use memory address as a reference, but there are 20% of the vendors who don't use memory address as a reference. Like there is one vendor of JVM. What he does, when an object is created, he assigns a unique identification number to it. And that unique identification number, he uses it as a reference. So what I mean to say, in Java, don't say reference is memory address, because it may be, it may not be. In fact, it's better we don't use the word memory address. We stick to the word reference. And so in this line of code, what you will say, A is referring to object of A. So new followed by call to the constructor. That is how objects are created. New will return the reference of the newly created object, which on the left hand side we are collecting in A. But now new followed by call to the constructor. Now what is a constructor? A constructor is a special type of a method. It's a method only, but it's of a special type. Now what makes it special? A constructor is a method. It's a special type of a method which has name same as that of class name. It has name same as that of class name. Second, it does not have a return type. It is such a method that it does not have a return type, not even void. Not even void. So constructor is a special type of a method which has name same as that of class name, does not have a return type, is called only once. It is called only once during the life cycle of an object. In fact, to instantiate an object. Instantiate means create an object. Like here, to create this object, we are giving a call to constructor. Now that's the only time in its life, in this object's life, this constructor got called. After this, it's never going to get called. So the constructor gets called only once during the life cycle of an object. In fact, to instantiate an object. And lastly, it provides storage space for variables. It provides storage space for variables. Now, to be honest to you, in class A, we don't have any variables. But yesterday, the other day in the first session, when we were talking about car class, we had those variables: speed, gear, clutch, brake, accelerator. We were talking about state of an object. The values in those variables at any given runtime moment will define the state of your software car. But state later, values in those variables later. First, variables need storage in memory. Who provides them? Constructor. So when you create, let's say, object of car, new car, bracket, bracket, new car, bracket, bracket, give a call to constructor. When that constructor will get called at runtime, it will actually create memory space for speed, gear, clutch, brake, accelerator. So it provides a storage space for variables. So I hope you got the 4 things about constructor. I repeat, a constructor is a special type of a method which has name same as that of class name, does not have a return type. It is called only once during the life cycle of an object, in fact, to instantiate an object. And lastly, it provides storage space for the variables. So coming back to this line of code, A is equal to new A. This right hand side, new followed by call to the constructor, will create an object. New will return the reference of the newly created object, which on the left hand side we are collecting in A. We also understood about what is constructor. Constructor is a special type of a method which has name same as that of class name, does not have a return type, is called only once during the life cycle of an object, in fact, to instantiate an object. And lastly, it provides storage space for the variables. Another thing, if I don't say A is equal to, I just say new followed by call to the constructor, what will happen? Object will be created. Definitely, object is going to create it, because just now we said how are objects created in Java, using the keyword new followed by call to constructor. Now also, we are using that new keyword. We are giving a call to the constructor. So object will be created. New will return the reference of the newly created object, but we are not collecting it. We are not collecting it. We are not storing it. So what will happen? We won't have reference to that object of A. We won't have reference to that object. Even that object itself does not have a reference to anyone. No one has a reference to it. He has reference to no one. No one can talk to him. He cannot talk to anyone. So don't you think it's an isolated object in this case? And again, in the first session, we understood isolated objects are useless. Objects need to coexist. They need to interact with each other. Isolated objects are useless. Now the beauty of Java, when JVM starts, when Java virtual machine starts, it internally starts one thread which continuously runs in the JVM, and his job is to find isolated objects. The moment that thread gets any isolated object, it destroys it and it frees up the memory. It frees up the memory. And this thread is what we call garbage collector. So garbage collector is a thread started by JVM, keeps on running in the JVM. His job is to find isolated objects. The moment he gets any isolated object, he destroys them and frees up the memory. So there is a professional who's taking care of your memory management. That's why, in fact, programs written in Java, they have stability in them. And since he's the one, that garbage collector is the one who's actually destroying your objects, you don't have to manually destroy, you don't have to do it. So in Java, we have the concept of constructors, but we don't have concept of destructors. Okay. So that's another thing to note. But anyway, in our case, this was just to talk about garbage collector. In our case, I will like to collect the reference. Okay. Now, the last thing about this line of code, how to speak about this line of code. If you're speaking with respect to right-hand side, you should say, I am instantiating object of class A, instantiating an object. But if you speak with respect to left-hand side, you should say, I am initializing variable A by making it refer to object of A. Initializing variable A. This lowercase a, variable a, by making it refer to object of a. Now, why did I tell you how to speak about it? Because when you use the verb instantiating, it should go with the noun object, instantiating an object. And when you're using the verb initializing, it should go with the noun variable, initializing a variable, instantiating an object, initializing a variable. So I hope you got this point. Now let's move ahead. B is equal to new B, open parenthesis, close parenthesis, call to the constructor. So in this line of code, you must have understood we are creating object of B, again new followed by call to the constructor. Again, that new will return the reference of the newly created object, which we are collecting in B variable. So at this point of time, that B will have reference to object of B. Now let's move to the next line of code. A1 equals to A. A1 equals to A. So what do you think we are doing? Are we creating object? No, not at all. Because there's only one way to create objects in Java. New followed by call to the constructor. We have not done that in this line of code. So really we are not creating object of class A. So what are we doing? We are copying the reference. The reference which is in variable A, we are copying it in A1. So A1 will now also have the same reference which is there in A. So A1 and A both now will refer to the same object of class A. So if you look at the figure, A is already referring to this object. Now A1 will also refer to the same object. Both will refer to the same object. Now next line of code. A1 dot M1. A1 dot M1. I think you're maybe thinking correct. Yes. We are calling M1 method. That A1 is referring to object of A. We are using that reference to call that M1 method. As you can see in the figure, A1 dot M1. So this M1 method will get called. Yeah, this line will get executed. And what will be printed on console is hi. Hi. Now let's move to the next line of code. A1 equals to B. A1 equals to B. Now this is something important. A1 equals to B. Look at this line of code and just try to think. What are we doing? What will happen? Here actually we have, in fact, I give you two options. If you're thinking right now, I give you two options. Option number one, reference which is in B will get copied in A1. And B has whose reference? B has reference to object of B. That reference will get copied in A1. That is option one. Option number two, this line of code will give us a compiler error. Why it will give a compiler error? Because if you go up A1 variable, you have declared it as of type A. Means what you have declared, what can be stored in A1? Reference of any object of class A. And here in this line of code, you're trying to copy reference of object of B in A1. So you're going against maybe what you have declared. So that's why the second option possible is that compiler will give an error. So what do you think is going to happen? You know what's going to happen? Option one, the reference will get copied. So if it is going in your brains that we are going to get an error, we are not going to get it. The reference will get copied. The reference which is in B will get copied in A1. So reference of object of B will get copied in A1. Yeah, you must be wondering that we have declared A1 to be of type A. Means we can store reference of any object of A. And here we are storing reference of object of B. And it is getting copied. How? We are doing nothing wrong. Whatever we have declared, the potential we have declared, we are doing the same thing. We are doing the same thing. If you go and see class B, it extends A. And a short while back, I told you, extends is the relationship. B is a A. B is a A. Here you have declared the potential. A1, what can be stored? Reference of any object of class A. And B is a A. Since B is a A, reference of object of B can also be stored. If B was not extending A, if it was not inheriting from A, then yes, definitely this line of code will give you an error. if B does not extend A. But if B is extending A, it has a is a relationship with A, you can store the reference. So here, if I put it technically, there is one important thing. A variable, let me mark it here, a variable declared as of type superclass, a variable declared as of type superclass can refer to subclass object, can refer to subclass object. Why? Is a relationship. A variable declared as of type superclass can refer to subclass object. Okay. The reverse is not true. The reverse is not true. A variable declared as of type subclass cannot refer to superclass object. Toyota Innova is a car. Every car is not a Toyota Innova. So reverse is not possible. A variable declared as of type superclass can refer to subclass object. A variable declared as of type subclass cannot refer to superclass object. So this will very well compile. Not only compile, it's going to run. And you know what is going to get, what is going to happen at runtime? That reference, which is in B, will get copied in A1. So A1 will also start referring to the same object. So if you go in this figure, A1 equals to B. So at that point of time at runtime, A1 will leave the reference of that object of A and it will start referring to object of B. That is what is going to happen. Now, after this line of code, A1 dot M1. Okay. Again calling M1, but this time this method will get called at runtime on object of B, because right now at runtime this A1 is referring to object of B. So M1 of B method, M1 of object of B will get invoked, which we have overridden. As you can see in B, we have overridden M1 method. So that M1 will get invoked, and what will be the result? Hello will be printed on console. Hello will be printed on console. Now, next line of code, A1 dot M2, A1 dot M2, A1 dot M2. Now just try to guess what's going to happen. Just try to guess. What do you think is going to happen? If you think that M2 method of object of B will get invoked and by will get printed on console, this M2 method will get called, by will get printed. So no, it's not going to happen. It's not going to happen. In fact, you know what's going to happen on this line of code? You're going to get compilation error. Forget about runtime. That printing of by and all will happen at runtime. Forget runtime. Before runtime, we need to compile the code. And during compilation, we are going to get the error on this line of code. Compilation error. Okay. Now why? Now this is a very important thing. Just now on this line of code, A1 is equal to B, I talked about the concept. A variable declared as of type superclass can refer to subclass object. A variable declared as of type superclass can refer to subclass object. But now something more to it. A variable declared as of type superclass can refer to subclass object, but it can only be used to access those members in subclass object which that subclass object inherited from superclass. Which that subclass object inherited from superclass. That A1, which is of type A, can refer to object of B. Why? B is a subclass to A. It can refer to object of B, but A1 can only be used to access those members in B which B inherited from A. Okay. That's the complete concept. Very important one. Okay. Now why? Try to understand why. Okay. Now A1.M2. When you had a look at this line of code, you must be thinking that A1 is at this point of time at runtime referring to object of B, so that M2 method of B will get called. That must be going on in your brains. But tell me, this object of B, A1 is referring to object of B. This will happen at runtime. Objects are there at runtime. Are there objects at compile time? Do we have objects at compile time? No, we don't have. Objects are created at runtime. At compile time, we don't have objects. So the big question comes, how does compiler work? Compiler works on data types. Compiler works on data types. Now, this is an important thing for you guys to understand. It works on data types. Just imagine this part of the code. This part of the code. How is compiler going to compile it? Let's take it line by line. Compiler, when he compiles this, if you are thinking two variables will be created, not at all, because variables will be created at runtime, not during compile time. So at compile time, what will happen on this line of code? Compiler will see that you are declaring two variables, A1 of type A. So here his duty, here his job is to check whether class A is there or not. If the class A is there, fine. If it is not there, he'll give you an error. But since we have that class A in our source code, when he's going to search whether that class A is there or not, he's going to get it. He's going to get it. He's going to compile it. Come to next line of code. B. Again here also. Compiler is going to check. You're declaring variable B to be of type B. So he's going to check whether that B class is there or not. Yeah, again, we have that class B in our source code. He's going to get it. He's happy. He's going to compile it. Third line of code. A is equal to new A. Again, if it is going on your brain, object will be created. No, objects are created at runtime, not at compile time. When compiler compiles this line, no object is created. Object will get created at runtime. So in this line of code, what is the duty of compiler? Two things he's going to check. Left hand side variable A, he will check that A is of what type? It is of type A. Okay, this A variable is of type A. And on the right hand side, which types constructor you are calling? Which types? Type A. Type A's constructor you are calling. Left hand side variable is of type A. On the right hand side, the constructor that you are calling is of type A. So both the types are matching. So he's fine with it. Types should match. Data types should match. Another thing that he's going to check, you are giving a no parameter, call to no parameter constructor. You're giving a call to no parameter constructor. That constructor has to be there in class A. It has to be there. You're calling a constructor, it has to be there. So he'll go in class A. He's going to go in class A and he's going to check whether that constructor is there. If he gets it, fine. If he doesn't get it, he's going to give you an error. But now if you see in class A, actually we don't have a constructor. Remember, constructor is a special type of a method whose name is same as that of class name, does not have a return type. Have we given any such method? Have we defined any such method in class A whose name is same as that of class name? No. Does not have a return type? No. So it's not there. So when compiler goes and searches, since you are calling, he's going to go and search. He's not going to get it. So he should give an error. But fortunately, again, he's not going to give an error. Why? Because this is again a new concept that you need to understand. Remember this. Whenever you don't define a constructor in a class, you get a default constructor. In fact, you get a ready-made default constructor. You know who puts it? Compiler himself. Compiler, when he checks all the classes, when he sees that in a class you have not given a constructor, he himself gives a constructor. So in this class A, since you have not given a constructor, he's going to put it something like this: public A, no return type, name same as that of class name, a special type of method, open brace, close brace. He's going to put that constructor. So this is again an important concept. Whenever you don't give a constructor in a class, you get a default constructor. And compiler is going to put it, that also pre-compilation. Pre-compilation, in whichever class you have not given constructors, he's going to put the constructor. While compilation, when he goes and checks whether that constructor is there, he's going to get it. He'll be fine. And he will compile this line of code. Of yours. Okay. Again, come to next line of code. While compilation, again, the first thing that he's going to check is, are the data types matching? B is of what type? B. On the right hand side, you have given a call to the constructor of which type? B. So left hand side, right hand side data types are matching. Again, since you are calling the constructor, his job is to go in class B and check whether such a constructor is there or not, whether a no parameter constructor is there or not. Again, you have not given any constructor in B. Since you have not given, you get a default constructor. He only will put it pre-compilation. So while compilation, when he goes and checks, he's going to find it. He's happy. Okay. Now come to this line of code. A1 equals to A. What is going to happen? Compile time. Again, if you think that reference will get copied, you're wrong. That reference will actually get copied at runtime, not at compile time. Compile time, there is no object, no reference. So compile time, what is the job of compiler on this line of code? To check the data types. A1 is of what type? A1 is of type A. A is of what type? Type A. Okay, both are of same types. Since the types are matching, he's going to compile. Okay. Next line of code, A1.M1. Again, if you're thinking that M1 method will get invoked, forget that M1 method will actually get invoked at runtime. So at compile time, what is the job of compiler? Here, what is the job of compiler? Again, he's going to check, since you're calling M1 method, he's going to check whether that M1 method is there in class A or not. There in class A or not. Why is he going to check in class A? Because A1 is of what type? It's of type A. So go in A and check whether there is a method M1, yes or no. Yeah, that method is there. So he's happy and he's going to compile it. If he wouldn't have found that M1 method in A, he would have given you an error. But he finds it, so he's happy with it. Okay. Actual M1 method will get invoked at runtime. Okay. Next line of code, A1 equals to B. Again, what is the job of compiler here? To check the data types. A1 is of what type? A. B is of what type? B. And B is a A. B is a A. He's going to check. B is a A. Okay. B is a A. So again, types are matching. Types are matching. He'll be happy. He'll be happy. So he's just going to go to check the types. The actual reference copying will happen at runtime. Okay. Now see here, A1.M1. Again, what do you think he's going to do? Now this is important. What he's going to do compiler. Again, you're calling M1 method. So his job is to check whether that M1 method is there or not. But where is he going to check? Where is he going to check whether that M1 method is there or not? Again, he's going to work on data types. A1 is of what type? A. A. So go in class A and check whether M1 is there or not. Yes, it is there. Yes, it is there. So he's going to be happy and he will compile this line of code. But something interesting, compiler works on data types, runtime happens on objects. At runtime, that A1 will, at this point of time, will actually refer to object of B. So the M1 method of object of B will get called. So if you see at compile time, when he's checking in class A, but at runtime, actual M1 method which will get invoked will be of B. Why? Because compiler works on data type, runtime happens on object. So people, actually you need to keep two thinkings, compile time thinking and runtime thinking. When you think about compiler, you think about data types. Don't think about objects. And when you think runtime, you just think objects. You don't think about data types. So you need to develop two thinkings, compile time thinking and runtime thinking. Whenever you're writing a code, you first look at it from compiler point of view. And when you look at your code from compiler point of view, you just think about data types. Once you think, yeah, it will compile successfully. Now you think about that code at runtime. Now, when you think about your code at runtime, you never think data types, you think about objects. Okay. So you need to develop two thinkings. So A1.M1 compile time, that M1 method will be checked in class A. But at runtime, since the things work on objects, at runtime, A1 will actually refer to object of B. So M1 method of object of B will get called. So that is how the things are going to work. Now come to the last line of code, A1.M2. Again, compile time. He has to check, since you're calling M2, he has to check whether that M2 method is there or not. Where he's going to go and check? Again, he's going to work on data types. He'll check A1 is of what type? A. So go in class A and check whether M2 method is there. No, it's not there. That's why he's going to give you an error. So at this line of code, he's going to give you an error. A 3-line typical error that he will give you. He'll 3-line error. On the first line of compilation error, line number 38, he'll show you line number 38. Cannot find symbol. He'll say cannot find symbol. Now, whenever Java compiler tells you cannot find symbol, so he's actually trying to tell you, I'm not able to find it. I'm not able to find it. What he's not able to find, that he will tell you on second line of code. What he's not able to find. Cannot find symbol, symbol method M2 bracket bracket. He'll say that he's not able to find method M2. Where he's not able to find, where is he searching? That he will tell you on third line of error. Location class A. He'll say I'm not able to find it in class A. So he's going in A and searching. Why? Because that A1 is of type A. So 3-line error, cannot find symbol, symbol method M2, location class A. So I hope this clears it. These two thinkings is a very important thing which I told you, because most of the freshers that I have noted, they don't have two thinkings. They just have one thinking, runtime thinking. But try to understand, you're actually supposed to keep two thinkings. Compile time thinking, runtime thinking. Compiler thinking, when you just think about data types, because compiler works on data types. And when you think about runtime, you forget data types. You think about objects. So that is how your thinking has to develop. So anyway, this last A1.M2, here we understood one important concept. A variable declared as of type superclass can refer to subclass object, but it can only be used to access those members in subclass which that subclass inherited from superclass. Very, very important thing. Okay. So with this, we'll end the session for now. Meet you in next session where we'll discuss about rules and conventions. So see you. Bye for now.